Okay, good afternoon. Uh, let's start some new stuff today. We actually get to do some almost real geometry here. We get to talk about midpoint and distance formulas, and that should be pretty good. Also, if there's anyone with artistic skills that can do better than this, because this seems like that's what's going to come up on my little thumbnails, and they look kind of terrible, and I think we deserve better than terrible. Okay. So we start with midpoint, the midpoint formula. So what that means is you're going to have a line segment AB. So that's going to be at 4, -6. So 1, 2, 3, 4, down 6. All right. So that's point A. And then point B is at -4. So 1, 2, 3, 4 back up to B. And we're going to say if we connected those with a line, like this, what is the point that is halfway between A and B? And so you're saying, I don't know, maybe right here? Maybe there's a really cool mathematical formula, and you'd be halfway right. There is a formula. It's not really cool, though. It looks a little bit like the midpoint will always be x1 plus x2 over 2, comma, y1 plus y2 divided by 2. And take a second and think about, oh, why does that work? While I fix my, oh, it erased all of it. While I fix my parentheses. Oof. Why? Did you figure it out? Well, think about what it is. You're adding our two values and dividing by 2. So really what this is we're finding the average. We're finding the average x value. We're finding the average y value, and it's going to be the point that's in the middle of the line. Okay, so let's work this out. So A has an x. We're going to call A x1 y1, and this one x2 y2. Doesn't really matter. We could switch these around and call this x2 y2 x1 y1, but this came first, so we'll call it 1. So x1 is going to be 4 plus -4 divided by 2, and then our y value is going to be -6 plus 2 over 2. And then we just got to work this out. So 4 plus -4 is 0. 0 divided by 2 is 0. Our y coordinate here, -6 plus 2 is -4. -4 divided by 2 is -2. And we kind of had the idea, but now we know very certain that our midpoint is right here. And we call that, I don't know, C. Oh, they already used C. Let's call it W for wow, what a great job. Okay, number 2. CD. So C is at 0, -8, 2, 3, 4, 5, 6, 7, 8. And D is at 3, 3, 0. So here's C, here's D. And again, we want to know what is the point that's right in the middle between these two. Okay, this one maybe not as obvious. You're thinking, oh, maybe it's this where they intersect. Wouldn't that be nice? So let's see. So use our formula. Again, we'll call this C x1 y1, D will be x2 y2, just to keep it simple. So we're gonna have 0 plus x2 is going to be 3 divided by 2, and then our y values we have -8 plus 0 over 2. So the zeros help out. That makes our math a little bit easier. So 3 divided by 2 is going to be 1.5. And -8 divided by 2 is going to be -4. So we'd say 1.5, 1, 2, 3, almost, not quite. And we'll call this H for how easy was that? Am I right? Aha, okay. The next thing, the other thing you can use midpoint formula for is if they tell you the midpoint. So we're going to make a kind of cheesy grid here. So it says point L is at -3, -1. That's L. And the midpoint is at 0, 1. And they call that M. And we want to know where would N be. So I'm sure they explained this to me when I was a kid, but I always just said, well, if we figure out how far it is from here to there, and then just do it again up here. So I'm going to say my midpoint's up in here. That's N. But just for fun, let's do it the mathematical way. So what we say is we use a formula. We say we already know our midpoint is 0, 1. Okay, and that's equal to, we said that's x1 plus x2 divided by 2, y1 plus y2 over 2, right? And so now what we do is we say let's call L x1, y1, and let's just substitute those numbers in, and let's do it with a different color because we're cool like that. So we're going to say this is -3, -1. So 0, 1 is equal to -3 plus, and this we don't know still, so we'll just call it x divided by 2. We don't know y, and y2 is going to be this coordinate. So this is going to be our x2, y2, and that's really what we're solving for, is x2, y2, right? And now we just sort of single these out. So if we're solving for x, we only have to concern ourselves with this mess here. So we're going to say, scroll down a little bit here, we're going to say 0 is equal to this over here. So -3 plus x divided by 2. Right? Now we just solve for x. So we remember from yesterday and from last year, to get x by itself, we have to get rid of this dividing by 2. So we're going to multiply both sides by 2. So 2 over 2 is going to cancel out. 2 times 0, that pretty much cancels out 2, because anything times 0 is just 0. So we get 0 is equal to -3 plus x. Last step to get x by itself, we just add 3, add 3. We need more page here. So we're going to get x equals 3. So our x coordinate here is going to be 3. And now we got to find y. So we come back, we say, well, we want this, and we want this. So we're going to say 1 equals -1 plus y divided by 2. And we do the same thing. Anytime you do midpoint, you're always going to end up multiplying by 2 times 2 times 2. This cancels. 1 times 2 doesn't cancel. That's just 2, though. That's -1 plus y. Okay, last step, get y by itself, +1, +1. Should probably be putting these lines in here just to show I'm doing math like a good boy. So 2 plus 1 is 3, so y also equals 3. Okay. And so that's some good quality work. So yeah, that's that. Not so bad. It's a little bit of work. Whatever. Alright, so that's number 4. Check. Let's do number 5 and say goodbye to all that hard work we just did. So B is the midpoint of AC. A has coordinates of -3, +4. B, which is our midpoint, is at -1.5, 1. So we can assume probably it's our missing point. This is A, B, C. So it should be down somewhere in quadrant 4. Let's try it out. So negative, and I'm not going to write a mixed number. I'm going to say -1.5, 1. And that's equal to, we're going to say this again is x1, y1. So we're going to say this is our midpoint formula. This is -3 plus x2 divided by 2 is our x coordinate. And our y coordinate is going to be 4 plus y2 divided by 2. Okay? And then again, we just isolate it. We solve for x on one side, and we solve for y on some other side. And then we just take those two, we get our coordinates, and we figure out C, and then we get to move on to ice cream. Yes, there's ice cream coming. Get excited. So negative 1.5 equals negative 3 plus x. And we could keep calling this x too, but I mean, there's only one x we're working with at this point, so it's a sort of extra numbers to write down. And we don't do extra work, because we're lazy in a good way. So we solve for x, so times 2 on both sides, cancels out. 2 times negative 1.5 is negative 3. So you get negative 3 equals negative 3 plus x. And hopefully you can see, well, negative 3 plus what number equals negative 3? I don't know, maybe 0? Just for fun, we can do it. Because we're good kids. Cancels, cancels, and x does equal 0. So I was a little off. Let's mark towards there. So our x coordinate is 0. Now we'll work out y. So 1 equals 4 plus y. That's in the wrong spot. My bad. 4 plus y, 2. Oh, I shouldn't even written it. I don't know what I'm doing. Ooh, oh, I just erased everything. What am I doing? Oh, okay. Okay, we're okay. 1 equals 4 plus y divided by 2. Oh, man. I'm falling asleep over here. Okay. We're okay. Times 2 on both sides. You tell it's been a while since I've done math professionally. So 2 equals 4 plus y. We get y by itself. We gotta subtract 4 minus 4. And that equals 2 minus 4 is negative 2. So y equals negative 2. So here's our coordinates. Alright. And we can also think about, I mean, if you want to check your work because we're good kids. We say negative 3, 4. So right in the middle between these should be b, which we said was negative 1.5, 1. And if you think about a number line, if here's negative 3 and here's 0, what's in the middle? Well, 1.5. Negative 1.5. And on the other part, in between negative 2 and 1, 2, 3, 4, if you just look for what's in the middle there, it's 1. So this works out. And really, I mean, you can skip some of this math. I mean, if the numbers aren't terrible, you can kind of get the idea and just say, well, if these are 3 apart, then half of 3 is negative 1.5. Or if it's from 4 to negative 2, they're 6 apart, right? So it's 3 away from 4 and 3 away from negative 2, and the only number that's 3 away from both of them is 1. So, I mean, if you got common sense, you can do some work with this, right? Okay. So, ice cream. I promised ice cream. So let's say we're getting ice cream, right? And one of you says, I want to go to the Cold Stone. No, we haven't go to Cold Stone forever. I want Marble Slab. I want the one on Saratoga. That's my favorite ice cream place. And your friend, who's a jerk, says, nah, I don't like the Marble Slab on Saratoga. I like the Marble Slab at the mall. And so you say, okay, we can drive over there. Kind of a jerk thing to do, but we'll go. And so you want to figure out, because you're math nerds, you want to know how far is it from point A to point B, conveniently noted on our Google Maps here. So the way you'd normally think about it is you'd say, how long along Staples did you go? And how long on SPID did you go? Which is 1.8 miles and 0.4 miles, which gives you a total of about 2.2 miles, right? And we call this is a taxi cab geometry, right? Because you're calculating distance, but it's not really how you calculate distance, because is this really the shortest distance or shortest possible way to get there? Because there's probably a faster way, right? what could possibly be a quicker way than driving down Staples and then driving down SPID? And you'd say, well, duh, I would just drive my car. I go through all these people's yards and I just make a straight line. And we're going to ignore this little drive down Saratoga. We're going to assume it's right at the corner. So if you don't like it, shut up. So we want to know how far is it from point A to point B in a direct line? How could we calculate this using our massive mathematical intellect? So take a second, work it out. Remember, this is 1.8 and 0.4. You can use a calculator if you want. You might want to pause. I'll let you work this out. Okay, hopefully you got it. So let's take a look. I changed my picture a tiny bit, but it's still the basic idea. This is to help people who didn't see it in the first place. And if we draw a straight line here, I cut myself off. Whatever, you get the idea. And you look, what shape have we made here? What did the fine people, the engineers of Corpus Christi, decide to do right here at Staples and SPID? They made a right angle, which makes this handy little drawing a right triangle. And so how can we find this missing length on a right triangle? And hopefully everyone said 2 seconds after I drew the first line, duh, this is a Pythagorean theorem question. Pythag theorem question. Okay, and that basically says what is a squared plus b squared equals c squared, right? So this is basically 1.8 squared plus 0.4 squared equals something. So we take out our calculators and we work this out real fast. I don't have a square button on here. That's lame. Okay, so that's 32.4 plus. Do I even have a parentheses button on here? This is the stupidest calculator. Oh my goodness. I don't erase my word. 32.4. 0.4 times 0.4. Why am I working that out? How am I stupid? That's 0.16. Woo! Oh, 16. What am I doing? This is the worst day. My mouse isn't working. 32.4 plus. I don't even know if that's 0.16 anymore. I'm so not confident in my abilities right now. Oh, what in the world? Why is my mouse not clicking what I want it to? Okay, let's go back and fix it. 0.4. Alright, so 32.56 our distance. Take the square root of that. I don't know, there it is. Okay. What in the world? Oh man, my decimals are all up in the wrong place. This is the worst example ever. I don't even deserve ice cream. Okay, I fixed this debacle that I was having with my calculator here. So we work this out and we get our answer as being, I don't remember what this came out to, but C is 1.84. So the actual distance from here, from one ice cream place to the other ice cream place, is only 1.84 miles. So by taking the roadways, you're driving an extra 0.4 miles. And I mean, it'd really be that hard? I mean, you got a park here, that's not so bad. You got a couple houses, and people might be a little angry, but when you got to get your ice cream, every 0.4 miles counts. Okay? So what does this have to do with the distance formula? That's an excellent question. So let's say we're not talking about ice cream and roads. Let's say we're talking about a grid. Okay? Right? So we have point A, which is at 1, -2, 1, -2, it's A, and B is at -4, -4. Okay, and we want to know how far is it from here to there. Think about it, think about it, think about it. Think about how this relates to the ice cream question. You say, wait a minute. If I use my blocks, I get this long distance. If I was driving, this would be 2 blocks by 5 blocks. 5 blocks? Yeah, so this would be 7 blocks. But we want the direct distance. So what we've made is a right triangle, and we just need to solve for our hypotenuse here. So we have a height of 2 and a base of 5. So really this looks like a squared plus b squared equals c squared. And that's 2 squared plus 5 squared equals c squared. And this doesn't have decimals, so I can actually do this one and not look like I'm stupid, which is always nice. Oops, c squared, c squared, c squared. We take the square root of 29 and we get like, I don't know, 5.4-ish. And that's our answer. But that's Pythagorean theorem. I haven't actually told you what a distance formula was, and hopefully you might be able to figure it out just by using common sense. It's the second time I've assumed you kids have common sense. I like to believe. So, the distance formula is not based on knowing A and B and finding C. It's about knowing your coordinates. So instead of using A squared plus B squared and C squared, we're going to be using the same thing we did with our distance form, which is x1, y1, and x2, and y2. And I would encourage you to pause and think about how you can use these letters in this formula and come up with a brand new formula that will tell you the distance. So pause now. Pause. Get it? Pause. Okay. Let me tell you how to do this. So what we look at, this let's start with x. So from here, from B to A or A to B, whichever way you want to look at it, the distance between them is 5. So just using these numbers here, how could we get 5? Right? So how can we get 5 from that? Well, if we consider that we're talking about our x values. Hold on, I'm switching songs here. I don't even care about this video. I just want to listen to music. Okay, so we're looking at what am I doing? Oh yeah, x1, which is positive 1, and x2, which is negative 4. We want to know how far is it from 1 to negative 4. I don't know. Well, it's the difference between them. So we say, what is 1 minus negative 4? Well, that just happens to be 5. Hey, look at that, 5. And then some people say, well, what if you didn't do it like that? What if you switch the numbers around? What if we said, what's negative 4 minus 1, right? Well, that's negative 5. But since we're talking about distance, and we went over this before, something that's always true about distance is that it has to be positive. And this is going to totally be irrelevant in a second, so that's okay. So part of it is the difference between x1 and y1. So we're going to write that down. So x1 minus x2. Okay. And then we also need to do the same thing for y. So that's going to be simple. So it's going to be y1 minus y2. Wait, do they put it as x1, x2? I hope they do. It might be x2 minus x1, but again, it doesn't really matter. And then we think, what do we do with these two values? So here's x, or a here, and y1 minus y2, which is b. So if we look at this formula, what did we do those? We added them. We added these two together. But what did we do? We didn't just take a and b. We didn't just take 5 and 2. We had to square them. So it's going to be x1 minus x2 squared, y1 minus y2 squared, right? And we're getting somewhere. So that is going to be equal to this distance, but it's not just this distance, that distance squared. So we think, what do we always do to get rid of squaring it? we have to take the square root. So we take the square root of that, and we have a mighty fine mess that we call the distance formula. So if you didn't get any of this explanation, like at all, you just need to remember this. You don't even need to remember this. I'm pretty sure this shows up on a formula chart somewhere. So it's not so bad. And checking my own personal formula chart, it does say x2 minus x1. So boo me. I'm wrong again. But I'm not changing it. It's the same thing. Get over it. You'll live. Okay, so this is the basic idea. You take the difference in x, the difference in y, square them both, add them together, take the square root, and you get your distance. Hooray. It's just like Pythagorean theorem, only with points. So let's practice. Let me erase this mess here. Okay, so let's try the next one. So we have negative 2, 7, negative 2, 3, 4, 5, 6, 7. That's x. And y is negative 2. Oh, it's going to be super easy. 2, 3, 4, 5, 6, 7, 8. And so this is y. And we're going to use our formula because that's what good kids do. But hopefully you can recognize this is a straight line going down. So really we can just count how far is it from here to there. There's no real, none of this is going to happen. That's okay. Let's do it the long way because that'll be fun. So x1, negative 2. Yeah, I'm going to keep going x1 minus x2. I don't care. I'm a rebel. So x1 minus x2. Not that it matters because they're both negative 2. Squared plus y1, 7 minus negative 8 squared, and we're going to take the square root of this mess. So negative 2 minus negative 2, we can add the opposite here and get 0. 0 squared plus 7 minus 8, minus negative 8 actually. Add the opposite is 15 squared, and we want the square root of that. So 0 squared is just 0. I'm not going to keep writing that down. 15 squared is 225. And then the square root of 225. Why did we not have to do this? Because we just squared it just to square root it. And we get 15 again. So our distance is 15. That's it. See, was that so bad? Nah, that was easy. Hopefully this next one will be more of a challenge. Not that any of these are really a challenge, but it'll give us more numbers to write down. Hopefully you're writing something down. Otherwise, this is just a miserable waste of your time. Miserable. Miserable? Did I spell that right? I think that's right. Misery. M-I-S-E-R-Y. You can check my spelling later. 2, negative 1. I wouldn't be surprised. I got almost everything wrong today. Negative 4. 1, 2. 1, 2, 3, 4. Plus 8, 2, 3. And the good thing about this formula, this distance formula, is you don't actually have to draw this picture every time. I mean, we would draw the picture if we're doing Pythagorean theorem because we could see it better, but if we're using the formula, this is just for fun, you know, because who doesn't like drawing lines? So x1 minus x2, so 2 minus negative 4 squared plus our y's here, negative 1 minus 8 squared, and then the square root of that. Okay, so 2 minus negative 4, a lot of these going on, so it's 6 squared. Negative 1 minus 8 is negative 9 squared. And kind of got to be a little bit careful of this, especially reading a calculator. That negative 9 would need to be still in parentheses. Because remember, there's a big difference between doing this and this. You only square this number here if there's no parentheses. So this would actually work out to negative 81. Whereas this one, the answer we want is positive 81. right? And square root still. Okay, so this is 36 and 81. And I guess if we want to be really technical, we label distance as d. I bet you can figure out why distance is d, but if not, it's because d is the first letter of distance. Now you know. Okay, 36 plus 81 is a number, 117. The square root of 117 is not a number I'm familiar with, so let's call it, I don't know, 10.8-ish. So the distance is about 10.8 units. And that's it, really. That's distance formula. Let's do one more. It's got pictures, terrible JPEG pictures. Oh my gosh. Rectangular living room shows electrical wiring to be run in a straight line from E to L. What is the length of these wires to the nearest tenth? This is a middle school question. For serious, why are we doing this? Look, this is a right triangle. 16, 22. Use a squared plus b squared equals c squared. I mean, you wouldn't even use distance formula because there's no x1, y1. So this is just 16 squared plus 22 squared equals, is anyone listening anymore, squared? 16 squared is 256. 22 squared is, I don't know, 444? That's not right. Is that right? Let's check. 484. Bad at math. 256 plus 484. That's 0. 14. 740. So the square root of 740, goes my calculator. Boring. I don't know. I'll let you figure that out. So that's distance formula and midpoint formula. And good night. I don't know. Remember, like, comment, and subscribe to get more quality entertainment. All right. Good night.